With a FOIL problem, we have to recognize that we have two binomials times each other. Again, the indexes will match. You will not see mixed match indexes in this class. So this is a FOIL. This is going to be the product rule, potentially through what we have, but the old stuff still applies. There's no radical here and here, so this is just a multiplication of those numbers. Get in the habit of coefficient times coefficient, radical times radical. Each time we look to multiply out. So first times first. Remember, this coefficient, it's not written, but it's understood to be a 1. So coefficient times coefficient is 2. Now, oftentimes when I've given this example, coefficient times coefficient, radical times radical, they say I have students do 2 and then plus. There's no plus. Plus or minus is in between these items. Okay? So 2 squared root of 7 times 1 squared root of 6. 2 times 1 is 2. Times square root of 7 times square root of 6 is square root of 42. If the indexes match, which they do, multiply the radicands. Always assume that you will have something to simplify down the line. Okay? So 2 square root of 7 times 3. The 3 is outside, so it gets multiplied to the coefficient. So we have 6 square root of 7. Negative 4 times 1 square root of 6. Negative 4 times 1 is negative 4 square root of 6. There's no radical there. And the negative 4 times 3 is negative 12. Okay? So, no radical there, nothing to take out. There's no perfect square here. There's no perfect square in there. Is there one in 42? Well, look at what we had. We had 7 and we had 6. This is 1 times 7. Over here we got 1 times 6 and 2 times 3. There's no 2 of the same item. I could start dividing by 4. It won't divide in. Okay? So I get 2 and 21, 6 and 7. So when we look at this, there's no combining of like terms that we can do like radicals because indexes match, but we cannot combine these. They don't have the same radical or a radicand. Remember, we cannot add the radicands. We cannot do 42 plus 7 minus 6, that type of thing. We cannot add our radicands. This is our answer. Sometimes we can combine them, sometimes we can't. Depends on what we have for the information. Okay? So, let's do this. 3 minus square root of x times 4 plus square root of x. So again, it's a distribution. So coefficient times coefficient, radical times radical. So here's what I'm going to do. I'm going to practice the box method. Okay, just give you a refresher on this, see if it helps. So the box method allows you to, if it's 2 terms times 3 terms, you just add another row or column. So I'm going to do 3 minus square root of x, and I'm going to do 4 positive square root of x. Where they intersect, you multiply. 4 times 3 is 12. 4 times the negative square root of x. This 4 is outside a radical, so it's a negative 4 root x. It's going to stay outside. 3 is outside the radical, so 3 times square root of x is 3 square root of x. And then we have a positive and a negative, so when you multiply them together, that's a negative. Square root of x times square root of x. There's various ways we can write it. Remember, index is the same, so we can multiply. X times x is x squared. Now, most times when we've done this on the diagonal, we look for the like terms. So we're going to have 12, negative 4 square root of x, positive 3 square root of x. Indexes match, radicands match. These are like radicals. So negative 4 plus 3 is a negative 1 square root of x. Minus, we have the square root of x squared. This is our simplification we've done in the past. Power matches the index, take out the base. Now remember, at this point, the instructions would say assume everything is positive. So we don't, even though that's even, we don't have to worry about the absolute value. Now some students will say, do we have to put this in descending order? We don't worry about that as long as there's a radical. If the radical wasn't there, if it was 12 minus x squared type thing, we would look to put it in descending order. We just have to have these, we can have this in any order. If we move those around, that negative still stays with that x. This is a positive 12. So that would be our solution. Okay, so I'm going to give you I'm going to give you two U-try problems, 1 and 2, and I'll give you both answers in the next clip. So your first U-try problem is going to be this. Not 3. 6 minus 4 square root of 5. So that's number 1. Number 2 that I want you to try is square root of 20 plus square root of 18 times square root of 10 minus square root of 27. Okay, so we will go over in the next clip both solutions, but this is U-try number 1, this is U-try number 2. Again, coefficient times coefficient, radical times radical for each one. So you can do box, you can do FOIL, double distributive if you want. When you get to this one, what I recommend is to go through, do whatever method you would. So take them, multiply them together, multiply the radicands, and then look to simplify. Can you remove perfect nth powers? In this case, can you remove perfect squares? And then see if we have any like radicals. Okay, we'll pick that up with the solutions in the next clip.